Okay, the second goal of section 8.6 is on the inequalities part. And the inequalities part is a lot like the equation part, just like any other inequality, but there is a little bit more to it. We are going to skip the word problems in the middle of, or the end of goal 1, or the middle of this section. So don't worry about those right now. Just worry about knowing how to solve equations and inequalities. All right, so when we start with solving an inequality rational equation, rational inequality, we're going to treat it like an equation. So we're going to solve it just like an equation. So that's our first step, is to solve like an equation. Okay, so we basically set it equal. So we've got 5 over x plus 6 over 5x equals 2 over 3. So just like we did the last 6 examples, we're going to go ahead and multiply everything by the least common denominator, 15x. All right, so I end up with 75 here. 5x goes into there 3 times, so 18 equals 5x, 10x. So this is, looks like, 93 equals 10x, so x is equal to 9.3. Okay? All right, if I did that right, that should be fine. I'm not worried about fractions or decimals, but you never know what the book, if I made a mistake, so I want to double check. Okay, it looks like I'm okay on that one. All right, now, here's the second step. The second step is to identify the excluded values. Okay, so the first step we got x equals 9.3. The second step we're going to find the excluded values. What values of x make the denominator 0? And that would be 0. The third step is to graph these two on a number line. Or you might end up with more than 2. You might end up with a couple solutions, a couple excluded values. Graph whatever you can. So here's my number line. Here's 0 right here. I know that that has to be an open circle. X is 9.3, which is right here. That has to be a closed circle because that's a solution. Now, we're going to test parts of the number line. So the fourth step is to test. Test each part. In this case, we have 3 parts. We've got the one that's on the left of 0, the one that's between 0 and 9.3, and the one that's on the right side of 9.3. So in the first part, we put in a number. We check a number. Let's try -1, because that's over here. The second part, we'll probably try 1. And the third part, maybe we'll try 10. So we're going to try these numbers and see if they work. If they work in the original inequality, they make the inequality true, then we know that that part is part of the solution set. Okay, so if I try -1, I end up with, I put it back up in the original problem. I'm going to double check to make sure you can see what I'm working on here. Yep, okay. I put it back in the original problem. I get negative 5, because 5 over negative 1 is negative 5, plus 6 negative 6/5, is that greater than 2/3? And you don't always have to do the total math. You can always look at the signs sometimes. I've got a negative plus a negative. That's negative. That is not greater than 2/3. So this is a no. That section of the number line does not work. If I put in 1, I get a 5 plus 6/5. Is that greater than 2/3? Well, yeah, it is, because 5 plus anything is bigger than 2/3. So this is a yes. If I put in 10, I get 1/2 plus 6/50. Is that greater than 2/3? You might have to do a little math here. You can do the decimals. This is going to end up to be a no. So my solution is everything between here and here. So everything from 0, whoops, that's a not including 0, all the way up to 9.3, including 9.3, or 0 is less than x is less than or equal to 9.3. There's my solution. So you just have to find the different marks on the number line and test in between them. So go ahead and try this one if you'd like, and then I'm going to do this one. You can pause the video right now and see if you get this right, but I'm going to go through it right now so then you can look at what you did right or wrong. Okay, so hopefully you tested this one and you're going to now see what the right answer is by going through it with me. And so first of all, we go ahead and solve it just like we would on a normal equation. So I'm going to multiply everything by 9x. I end up with 12 plus x goes in there 63 times equals, remember we're just doing equals now, 5x. So this is 75 equals 5x. X is equal to 15. That's my solution. Now the excluded values, in this case, is 0 again. So we're going to go to a number line. We've got 0 here, we've got 15 here, and I know it's an open circle on 0, it's a closed circle on 15, and we're going to try, let's try -1 again, let's try 1, and try 16. Smaller numbers as possible is usually the best. All right, so 4 over -3, so -4/3 plus -7, is that less than 5/9? And that's a yes, because they're both negative and that's less than. So this is a yes. 1, we get 4/3 plus 7, is that less than or equal to 5/9? And of course that's a no. And the last one, we've got 4 over 48 plus 7 over 16, is that less than 5/9? And I think if you did the math on this, this would be a yes. So my solutions, everything from this way and everything here this way. So to write that, I would say -infinity all the way up to 0 union 15 all the way up to infinity. Or I could say x is less than 0 or x is greater than or equal to 15. Either one of those would be the correct solution.